Good day all. In this video I'll be talking about how to digitize well logs in order to change them from this format where you have your depth, your gamma ray, your SP, your RT, RXO into something like this, where you have your gamma ray line, so you can see easier where is your sandstone line and your shear line. Okay, so the first thing we do is that we create a text file that doesn't have the headers and everything that's not related to the logs from the wireline. Okay, so it's going to be something like that. Then we import it to Petrel. Okay, so in order to import to Petrel, we import it from here. The file type is well logs, and we are doing well for, so it's this, and we click OK. So we insert a new well and we call it well 4. Depth of well 4 is the depth of the lowest reading. So the depth here is 6558 meters. So 6558, and the unit is in meters. Click OK. So we can remove this one. We have our well 4. So on this well 4 we import well 4 there. So our first log is depth. It's column 1. So this is depth. Then gamma ray. Depth, gamma ray, then SP. Then RT, RXO. Then density, sonic. Then neutron or CNL, compensated neutron log. Okay, so depth is column 1. Gamma ray is 2, SP is 3, RT is 4, RXO is 1, 2, 3, 4, 5, density is 6, and CNL is 8, sonic is 7, CNL is 8. So the property for depth is elevation, this one is gamma ray, this is spontaneous potential, resistivity deep, and flushed zone resistivity or shallow resistivity. Then you have density, sonic, and neutron. Then we go to window and new well section window. Then we activate them. We have our gamma ray, we have our RT, RXO, and density and neutron. So the first thing is we just adjust the depth we want to look at. We can zoom in like this. So we can see the whole log. The next thing we do is we set the minimum and the maximum ranges for each track. So this is very important because changing the minimum and maximum will change the overlapping or the butterfly effect. This will change your judgment whether you have gas, oil, or you have hydrocarbon or you don't have hydrocarbon. So gamma ray is from 0 to 150. One more thing is that all these logs are linear except for resistivity. RO, RXO, and RT are logarithmic. So gamma ray is from 0 until 150. RT RXO is 0.39 the minimum and the maximum is 78379. We go to Windows, well section, we drag and drop RT and XO so they are both on the same track. So you can see that RT and XO are now both on the same track. If we double click on this, we're going to see that it's logarithmic. We can change the color. Let's say RT is green. We do the same thing for CNL and density. CNL is from 45 until -15. So this is -15 and this is 45, and then we reverse it. Density is 1.86, 2.86. So we do the same thing, we add CNL density by drag and drop. Okay, now the next thing we do is that the filling. The filling helps us to easily identify where is our crossover sections, or we call it the butterfly effect, where when, for example, when the density in red is less than the CNL, the size of this separation gives us whether it was gas or oil. Same thing, the separation here between RT and RXO gives us whether we have hydrocarbon or not, or we have fluid or not. So we do that from curve filling. So from curve to curve, and we fill it with, let's say, a yellow. So we can see here that when RXO is less than RT, it means we have a hydrocarbon. We do the same thing for CNL density. When density is less than CNL, the curve should be filled. Next thing we do is we create the facies log, which is this one. We can create a new discrete log and we choose facies. So we need to add a new track. We activate the facies, we're gonna have a facies track. Okay, so the X is on the yellow box, it means this is the sand. So all we need to do is just look at the sand line, which starts from here, and just drag and drop. So this is our sand zone. Other sand zone we have is this one. This is our second sand zone. These are small sand zones. If you want to change to shale, just right click and pick shale. can see the box now is on the shale. So this is our shale zone. We can either increase or decrease the sandstone as shale zone. Also, this is another shale zone, and depends on what you have. Fine sand, coarse sand, you can annotate this in this track. The next thing we do is the horizons, or these lines. So we go to create edit well tops, and we make the horizons, each two horizons make up a layer on the sand, on the sand zones. So this is the first horizon, and we add the second horizon. In this well we have 8 horizons because we have 8 layers of sandstone. You can finish the rest. We have another horizon also. Okay, so the point of the horizon is later on when we build the static model, each two horizon, for example, or these two blue horizon, they're gonna form the first layer. Also, another thing is that the horizon here, we can see that when we plot all the wells we have, we can see the effect of the topography and the contour map, where the layer 1 goes up and goes down and goes down further down. So that's the point of the horizon. At the end, the horizon gives us the wellhead data. Okay, sorry. So the horizon gives us the well tops. For example, we are working with well 4. We can see that well 4 we have horizon 1, 1, and till horizon 8, 8. This data is in the well tops. We'll use it later on for the reservoir engineering part. Okay. So at the end, you can see that from the correlation and from the pressure and depth gradient, we can determine our oil water contacts, and we can draw this map, which shows here is the gas, the blue is the water, and the green is the oil. The black one is we have a cell between these two layers. This is the end part of the geology. So all we need to do is we're gonna add the rest of the wells, and then we're gonna export the graphic, and we just name it whatever we want. Let's say well code. So we have it here. Thank you very much.